We live in a world completely dependent on positioning systems. A car without GPS stops. An aircraft that loses satellite signals immediately switches to emergency mode. Yet within the same atmosphere,
Switching
tiny
to
creatures
emergency
weighing less
protocol.
than 100 grams can travel
Initiating diversion
10,000
checklist.
kilometers
Stand by for
without
reroute.
losing their way, without signals, without maps. This is not a biological miracle. It is a natural data infrastructure where Earth, light, and chemistry combine to form a navigation system whose precision surpasses artificial technology. If humans built the global positioning system with 24 satellites, nature has long operated a biological positioning system, running 24/7 within molecules, winds, and every photon striking a bird's retina. The bar-tailed godwit is one of the most spectacular examples of this natural supply chain. Each year it flies more than 11,000 kilometers non-stop from Alaska to New Zealand, crossing the Pacific Ocean for 8 continuous days. No food, no water, no landing. Compared to a jet aircraft, this journey is equivalent to flying non-stop from London to South Africa without refueling something even a Boeing 787 cannot achieve. How can such a small creature perform this logistical miracle? The answer lies in energy optimization. Before departure, the bird transforms nearly all unnecessary muscle mass into fat, the highest density biological fuel, delivering 9 times more energy than carbohydrates. It redesigns itself into a biological flying machine, tuning lift-to-drag ratios to the limits of physics. But energy is only part of the equation. The true challenge is navigation, because a deviation of just 1 degree over 10,000 kilometers would send the bird into the ocean. This means its navigation system must operate with an error margin below 0.1% comparable to the precision of an atomic clock. Unlike humans, birds do not rely on a single GPS device. Instead, they use a layered system that automatically switches between navigation protocols depending on environmental conditions. During the day, they use a solar compass, measuring the angle of sunlight to determine relative direction. Their internal circadian clock continuously corrects errors caused by the sun's movement. At night, the protocol shifts to astronomy. Constellations are recognized not by position, but by rotational speed around the celestial pole. And when clouds obscure the sky, birds activate a magnetic sensor, a quantum mechanism within the protein, cryptochrome 4 inches, the retina. This system functions like a multi-channel network protocol, always maintaining redundancy. If one signal disappears, another instantly compensates, much like the internet rerouting data when a server fails. Nature solved the problem of redundancy tens of millions of years before humans formalized it in systems engineering. Over the ocean, where landmarks vanish and light conditions shift constantly, seabirds rely on a sense humans have largely lost: smell. Each oceanic region carries a distinct chemical signature: sulfur compounds from marine algae, nitrogen traces from continental currents, and volatile organic molecules released by ocean microbes. These molecules drift with the wind, forming an olfactory coordinate grid, an invisible 3-dimensional map of scent. Studies in Italy and Japan show that when seabirds' nostrils are blocked or airflow is disrupted, they immediately lose orientation. This proves that smell is not only for finding food, it is a chemical navigation protocol, where every gust of wind carries positional data. In other words, wind is not just air to them, it is a network signal. The infrastructure of the sky is not limited to light or magnetism. It is also the molecular language of the planet. When we observe a migratory bird, we are witnessing a machine that integrates biotechnology at the levels of physics, chemistry, and quantum mechanics. Inside the retina, cryptochrome acts as a quantum magnetic sensor, decoding direction through changes in electron spin. Inside the nose, olfactory receptors convert air into chemical data, building real-time scent maps. Inside the brain, the hippocampus merges these signals into an internal navigation interface, a kind of biological augmented reality, where space is layered with invisible information. All of this operates using only a fraction of the energy required by artificial GPS devices. A bird does not think about direction. It exists within direction. At this level, there is no boundary between biology and engineering, because the body itself is technology. If humanity is only now entering an era of bio-integration, birds have lived within it since the beginning. They are nature's data engineers, operating a biological infrastructure network without cables, without radio waves, only with Earth itself. We often see birds as symbols of freedom, but their freedom comes from strict adherence to physical and biological laws. Each wing beat is not improvisation, but the result of millions of simultaneous quantum, chemical, and aerodynamic calculations. What we call the wild is actually a vast engineering network, where every organism acts as a node, interacting, synchronizing, and exchanging information across the layers of the planet. When humans lose signal, we panic. When birds lose stars, sunlight, or wind, they continue, because they carry the infrastructure of the sky within their own bodies. They do not fly by the map. They are the map. And perhaps, in a world increasingly dependent on artificial data, the most resilient positioning system is not in orbit but within life itself.